Hi everyone, my name is William, fourth-year PhD student at Georgia Tech, and I will follow up Taekyung and Sai's explanation of ASTRA-sim and proceed with the network layer explanation and the demo section. As Taekyung explained, the workload layer manages the workload-specific characteristics like parallelization and training loop, and the system layer from the workload layer specification initiates the actual collective communication. The network layer is the backend of this ASTRA-sim frontend and actually simulates the network behaviors, which can include like communication protocols, network topology, bandwidth and latency per link, offloading, compression, arbitration, buffering, and so on. So the interfacing between the ASTRA-sim frontend and the network backend is defined through some common network APIs. So the more explanation of this network API is in our Hot Eye 20 paper. And these are some core example network API methods. So for example, sim-send, the first method, the ASTRA-sim frontend requests the network backend to simulate a communication between some specific NPU source through the destination with some message size. And when this transmission has finished, to invoke the callback function so that the frontend can get the sense that this communication is done and proceed to the next operation. Similarly for the sim receive, and even simpler methods like sim schedule, which the frontend is just telling the backend to invoke the callback function after some delta delay, or some simple functions like sim get time, which the frontend is requesting the backend just to return the current time of simulation. So whenever the network simulator has implemented this network API inside the network layer, inside the network simulator, you can initiate this, instantiate this network API and the system layer and initiate the ASTRA-sim frontend. Then as the network backend runs the simulation, the frontend, the network backend communicates with each other and runs the distributed training simulation. So those are the main entry points of each network backend. So among the all possible network backends out there, we currently support 4 types of network simulators. The analytical backend, which is purely based on analytical equation-based simulation, is for fast simulation for large-scale systems. Analytical with congestion-aware feature, which is to model simple congestion behavior of the network. We also support Garnet, which is more suitable for simulating on-chip and scale-up networks, and also NS3 backend, which is for data center like parallel GPU clusters with internetworking switches. So here's the specific explanation of the analytical backend. So here in this backend, we only leverage analytical equation to model the network behavior and doesn't do other complex stuff. So we estimate the network delay by using the simple equation shown here, which consists of link delay and serialization delay. And the sim-send API does nothing but estimate the network delay and schedule the callback function after this delay. Because of this, the simulation is really fast for large-scale systems, but we are not modeling complex network behaviors such as congestion control or arbitration. So more details of this analytical backend will be in our coming ASPLOS paper, and this paper is now published on arXiv and will be available by tonight. So because of this limited behavior, we made another taste of analytical backend with some first-order congestion modeling. So here we at least have some first-order queuing delay, and how this is done is by when a specific transmission is given, we break this send into per link basis, and per link send and receive can be queued within the link. So because this is still based on the equation-based analysis, the simulation is still fast, but we can at least do simple network congestion modeling. And the Garnet backend, of course, the name suggests, leverages the Garnet, which is the interconnection network simulator, as the network backend. So this is appropriate for on-chip and scale-up networks. And Garnet backend can simulate the common interconnection network behaviors, such as packetization, credit-based flow control, congestion modeling, and whatnot. Because of this, it's slower than analytical backend for large-scale systems or large-scale workloads, but it can get more accurate results when these network behaviors are your target of interest. And finally, the ASTRA backend is suitable for largely parallel GPU clusters using some inter-networking connectivities. So these are some suitable topologies for ASTRA backend, like multiple GPUs connected via top of the rack or spine switches, and etc. And more details about this ASTRA backend are inside our hot eye paper published this year. So for each network layer, because of this different specifications and characteristics, we can have like different network input files. So this is the quick explanation of the network layer.